Hey everybody, this is Mr. Munson, and we are in Unit 10, Transformations. This is 10.1. We're going to look at some symmetry, basically something called line symmetry, point symmetry, and rotational symmetry. Let's get started. All right, now I'm going to take this shape, and I'm just going to, do a basic outline of it real quick. And what I want to show you is this shape has what we call rotation or line symmetry. Basically what it's saying is if I draw a line down some way, this is a vertical line, if what's on the left hand side matches what's on the right hand side, it's got line symmetry. Now this is in the natural. There's probably some little differences here and there that do not make it really have line symmetry, but I'm not going to play that trick with you. I need you to just understand what line symmetry is. Now this particular figure has multiple lines of symmetry. There's another one that would come down like this, another one that would come like this, and so on. Agreed? All right, line symmetry. All right, so let's take a look at this check mark and ask ourselves, does this have line symmetry? So I can't think of anything. If I drew something like that, I know that if I fold it along that line, what I see over here is not going to be reflected over to this side. It's just not going to happen. And if I was to cut it down the middle here, the same kind of similar stuff would happen, that what's on one side of the line of symmetry is not appearing on the other, right? Now remember, this would be flipped. Let's go ahead and flip this here. That didn't work. My software won't allow me to flip it the way I want, so this piece should match this piece on this side, but there's nothing over here like that. So this thing, what we conclude, does not have line symmetry. Now let's take a look at point symmetry. Point symmetry is basically if I can take the shape and rotate it 180 degrees, then it has point symmetry. Okay? 180 degrees. Now what I'm going to do is I'm going to add an arrow to this. Now that arrow is going to help me, indicate 180 degrees. So 180 degrees rotation will be pointing to the back. Now keep in mind, my software doesn't rotate about the center of my figure. So imagine if I put a compass right there in the middle and I just start rotating this around that circle, right? Okay, so I'm going to take it down to 180 degrees and I'll just realign it. So once it's there at 180, let's bring it back. And sure enough, it maps it back onto itself, okay? Now I want you to know again, there's variations here because it's in the natural. But the idea is that it rotates 180 degrees. I would want you to know that. Now, if this was a really high technical class, I would say definitely this does not rotate back onto itself. There's way too much distortion in it. But the idea is there for you to understand. Okay, so now when we look at this shape, we want to know, does it have point symmetry? So, it's going to rotate about some point in the center. Now again, my software is not going to let me do that, but I'll readjust it. Now, as I come around, I know already when I first looked at it, it was not going to work. Because see, there's going to be no point down at the bottom, and it was just another straight side, right? So I knew it wasn't going to work from the very beginning. But what if we just rotated it so that it was like this? Now, that's not 180 degrees, as you can tell, so it doesn't have point symmetry, but it does have the next content, rotational symmetry. All right, so when we take a look at this figure here, we can anticipate that it's going to have rotational symmetry, right? So if I have my arrow kind of pointing at the North Star there, I already know that when I rotate this thing all the way 180, it's got point symmetry. So we know that. Now what we want to do is, does it rotate onto itself over and over? And as you can see, for all intents and purposes, it does rotate back onto itself. Once then, and let's see, it would rotate here, and then it would rotate here. If we realigned it, it would be pretty close, right? And then here, and then here, and so on. Whoops, I got the wrong thing there. Let's get back onto that. There we go. And there, and there. So even looking at the figure, you probably have an idea it's got rotational symmetry. So from this point to there, it would rotate back onto itself. And another one, Once I rotate it once more, it's here, and then another one here, and then of course we already have the next one. We already knew it was going to go there because of the point symmetry. But then it rotates again and again and then again. And then it rotates back onto itself. I'm going to change this one into blue. There we go. And then it rotates itself back onto itself, which every object has 360-degree rotation, right? Go all the way around. I rotate the thing 360 degrees, it maps back onto itself. Okay, so I want to look at this and I want to ask myself, how many degrees of rotation is that, right? So that's so many degrees of rotation. And how would I end up calculating that? So what I would tell you is this. It's 360 degrees all the way around. And it rotates once, twice, 3, 4, 5, 6, 7. Of course, it rotates 8 times, which will get it back to 360. Okay, so we have 8 times. What I want to do is find out how many degrees is each one of these rotations. See if you can figure that out. See if you can figure out how many degrees is each one of those rotations. It's the same amount. So you got to figure out how many degrees you're working with and how many of those identical angles would you be dealing with as you rotate it all the way around. Put me on pause and see if you can think that through. Maybe draw the picture and just think it through. Put it in your head. Okay, so what we find is this shape has rotational symmetry, and after taking 360 and dividing it by 8, because there's 8 places, it has a rotation back onto itself every 45 degrees. Now let's list those angles. It's going to have a place where a lot of students will make mistakes, so pay real close attention as I do this. So at 45 degrees, it rotates onto itself. At 90 degrees, it rotates onto itself. So if you look down at the bottom there, I have all my angles, and basically I just took 45 and kept on adding it, right? So I got 45, 90, 135, 180, 225, 270, 315, and then back to 360. Now you never list the 360. That's the one everybody has 360 degrees rotation. I'm more interested in these in this drawing. These are the angles in which it rotates back onto itself. Now let's count how many of these we have. 1, 2, 3, 4, 5, 6, 7. You should always have one less than the total that takes you all the way around. Why? Because you're deleting the last one. Cool? All right, here is an equilateral triangle. And so what I'd like you to do is I'd like you to see if you can think through if it has line symmetry, point symmetry, and rotational symmetry. If it has line symmetry, go ahead and draw in the lines. If it has point symmetry, then state yes. And if it has rotational symmetry, see if you can decide at what angles does it rotate back onto itself. Put me on pause, come back and check your work. Okay, well those are 3 lines that I believe has line symmetry, meaning that if I folded it on any one of those lines, what's on one side would map onto the other side. Now, I disagree that this has point symmetry, and I'm going to show you, which is much harder to do on your paper because you can't really, clone and all that stuff. Now, what you could do is I'm going to take this drawing and I'm going to clone it. Now, what you could do is you could take another piece of paper and put it on top of your paper and copy it. Now, I'm going to change its color so that I can see what's going on. You could just take it and put it on top of another piece of paper on top of it, and then rotate it around and see if it has rotational or point symmetry. Point symmetry would be once I rotate it 180 degrees, it's back onto itself, and that's clearly not good. Okay, so it has line symmetry. It does not have point symmetry, but does it have rotational symmetry? Let's just put an arrow on it so we can see what's going on, and then we'll rotate it, right? Let's see if it rotates back onto itself, and it should because it's an equilateral triangle. And there you have it. That's one rotation. Of course, I could see that's 2 rotations, and the third one takes us back home. So let's calculate how many degrees each rotation is. Cool. Every 120 degrees, it shows rotational symmetry. So I'm going to list them: 120, 240, and of course 360. I'm not going to ever list that. You don't list it because it's not going to be allowed. Okay? So those are our degrees of rotation. And that's all you need to know. All right, thanks. Hope that's been helpful.